the Cerevisiae are, the temperature would go up by about 5 degrees Celsius by the end of that second stage burn, and that was perfectly okay. So it starts out cold. So apparently that was true because, look, we got data back from outer space. So this is the experiment run on the ground. This is run in space. The color coding is for the different concentrations of the antifungal drug. So blue is a control. Green is the low concentration, and obviously the low looks a lot like the control. Yellow is a medium concentration, right around what people would call the minimum inhibitory concentration of this antifungal drug, and red is the high concentration. And so you can kind of see they cluster in the multiple curves. There's a curve for each of 6 wells here.
So what's the y-axis?
So the y-axis is it's an optical signal, and it's the optical signal of a dye called Alamar blue, which changes from blue to colorless. So this absorbance up here, which starts somewhere around, I think, 1.5, is when there's a strong blue color, and then the blue goes away, and this is colorless down here. So we're just looking at the disappearance of blue color. We use that dye because we can count organisms also, but it's not as sensitive. You don't get the signal to background that you get by looking at this viability dye changing color. The interesting thing we saw here was a lot like what we saw in GeneSet, actually, and that is, again, if you look at the exponential phase of growth somewhere in here, and in there, and there, the ones in space grow about half as quickly as the ones on the ground. Except for, you might have noticed, the red curves here with high concentration of the antifungal. On the ground, the growth is pretty much totally inhibited. There's a tiny bit of metabolism, but not much going on. In space, they are metabolizing. And we know from our optical density measurements and some other experiments that while these kinds of